short presentation has been prepared to try to illustrate what happens when an object falls from height and how you can assess the risk in order to establish a suitably sized exclusion zone. It is based on research done by Tara Nixon of Select Plant and is for internal use only. It is only meant to be used as guidance. So firstly, some basics. When an object is dropped, unless it's acted on by an external force, it will fall straight down. When it hits the ground, it will bounce. Now I know we're looking at the risk from height and it's often windy, but at the speeds we erect cranes, unless the object is light with a large wind area, it's unlikely to be deflected far by the wind. The height of the bounce depends on the energy lost. If it hits a hard surface, so a metal ball hitting a metal surface, it will bounce much higher, whereas if it hits a soft surface, the energy lost is high, so the bounce will be much smaller. The direction of the bounce will depend on the angle of the surface it hits. If it's level, it will just go straight back up. But if it hits a surface of 22.5 degrees, it will deflect it for 22.5 degrees, giving us a worst angle of 45 degrees for a combined angle. Now that's probably the worst case for us at ground level, as it gives the greatest deflection. The harder the surface, the further the bounce. We undertook a number of experiments to establish how practice compares to theory. We prepared a calculator to predict the length of the first bounce depending on the weight of the object, the starting height, and the angle and hardness of the impact surface. Here we see the experiment being done. The initial research showed that in practice an object goes about a third of the theoretical horizontal distance. This can be explained through energy losses from the impact and other factors such as surface area and air resistance. There is a point after which an object is too heavy to bounce. After the first bounce, much of the energy is lost. So whilst an object may injure someone on impact, it is likely to be low down and with a lower severity than a full impact from full height. So here we use the theory to look at an object falling to the ground to assess the risk. Firstly, look at the starting point. What's the height the object could fall from? Now look at the objects which could fall. How heavy and hard are they? Remember, the heavier and harder the object, the higher the first bounce. Now look at the potential impact area. How hard is the surface? The harder the surface, the higher the bounce. If you see the graph on the right, it clearly shows how the hardness of the object and the surface affect the distance it will travel. A hard object hitting a hard surface is the blue line. Now what is the angle of the surface it's going to hit? That will help us calculate the distance the object will travel. Is it possible to clear the area to increase the chance of the object hitting a horizontal surface? Then it's not going to deflect anywhere, it's just going to bounce up. The graph clearly shows how the angle affects the distance the object will travel. Now remember, we're only calculating the distance to the first bounce. It's important to consider what happens after that. Is there an edge it could fall over? If so, we need to protect it. We also need to look at the rest of the area to consider where it's going to go after that first bounce. We also need to consider that the object could be deflected at height. In this case, the theory changes. The object will continue to travel horizontally on its trajectory, so our worst case deflection angle may no longer be 22.5 degrees, as can be seen on the graphs on the right. It very much depends on the height the object falls. So let's show that in an example. So if we allow our erector to accidentally drop a pin from a tie bar, it's going to fall 1.5 meters down to the jib, and it's going to hit the jib at a magical 22.5 degrees, which is the worst case for this example. So from our theoretical calculator, at the height of that drop, it will deflect 1.47 meters. That's at the same level as the first impact. Then carries on to the ground and hits a steel pyramid with a surface angle of 22.5 degrees. That gives us a deflection angle of 45 degrees, which is our worst case for an object hitting the ground. So the total fall distance was 21.5 metres. The initial deflection at the level of the jib, which will be illustrated by the red dot on the graph on the right, there, is 1.47, but it carries on to the ground, and by the time it gets to the ground the total deflection is 6.19 metres by theory. It then ricochets off the pyramid and follows the path on the graph on the bottom. That gives us a further deflection of 19.39 metres by theory. So we know with both of those figures we can divide them by 3 in order to get our practical distance. So that gives us a total distance that the object has travelled of 8.53 metres. So in reality our 8.53 metres might mean that we have an exclusion zone of around 10 metres or slightly more. The object can still bounce along the ground, so we need to take account of that by maybe installing some fences or blocks or sandbags at the ground level just to ensure that we contain it. So here's some guidance on preparing your risk assessment. So firstly, consider what work is being done and what items could fall. So can they be removed? So don't take up unnecessary tools with you. Change the method of installation. Try and make sure all the same size bolts are used all over the machine. Things like that to just limit what goes up there in the first place. Then look at what is being taken up and try and ensure that it's all tethered. If we can tether things, that prevents them falling in the first place. It makes it a much easier circumstance to manage. And then lastly, what is there to actually prevent something falling? Is there mesh on the handrails? Has the gap underneath the handrails been closed up? Are there any other gaps around the machines you could cover over? Use of the magnetic crane mats are ideal to try and prevent anything falling. And then the last thing to remember is irregular shape objects such as spanners and bars. They're really hard to predict where they're going to go. They can ricochet in any direction, so they're really hard to manage. Please tether them and ensure that all objects that are tethered all the time. So when you're using them and also when you're not using them, attach them to the handrail or something. Ensure that they're tethered. Now consider what's likely to be hit as the object falls. Is there parts of the crane structure immediately below where you're working? Are there crane ties? Is the scaffold that protrudes out immediately below where you're working? Or formwork and steelwork? Also be aware that an erector might try and catch something, so that's going to push it out slightly. So try and calculate what those things are and what height they're at, so we can use those in our calculations. Now consider what it will hit when it gets to the ground. Is the ground flat? Is it soft? Can objects in that area be removed or covered up? And then how hard are they? So from all of that information we can try and calculate how high something will bounce and how far it will bounce. Now consider what happens after that bounce is done. The object's obviously going to carry on along the ground potentially, so we need to look at where it's going to go. Could it go into the public area? Could it go onto a road or a pavement? In which case, we maybe need something just to protect at low level. A fence or a bit of barrier or even some sleepers or something like that, just to close off the area, make sure something can't scoot underneath the hoarding. Remember, it's got energy, so the exclusion zone needs to be bigger than what we calculate. Personally, I'd never have an exclusion zone less than 10 metres, unless you're working at a very low height. Now, with all the information you've got, contact application engineering for a calculation, and we'll try and give you some indication of how big the exclusion zone should be. And then you can look at what risks are in place and discuss it with site. Site is responsible for establishing and managing that exclusion zone. If anyone appears in it while the guys are working, they need to have a clear instruction to stop work and not recommence until that has been corrected. Now, I hope this information has been useful. Please contact us if you've got any further queries.